Okay. So now we'll be solving problem from RL, RC or RLC circuits, this chapter. So this is the circuit and they are asking, in the following circuit, the 12 volt source has been applied for a long time. Okay. So this was connected earlier, now it's disconnected. Before the switch opens at t is equal to 0, so at some t is equal to 0, you will be opening the switch. At t is equal to 10 microsecond, the current IL, so we need to find IL at 10 microsecond. What will be the current passing through this? Okay. Okay. So when they're saying that it was connected, this switch was connected for a long time, right? So what does it mean? So it means that the circuit has reached a steady state. Whenever there is a capacitor or inductor, it takes some time to reach steady state because it charges to that point. So when they say it's a long time, that means that it has reached a steady state. Okay. So when this was connected, what was the current flowing through this guy? So when this reaches steady state, assuming it's an ideal inductor, it will act as a short circuit, means it will have zero resistance. So basically in steady state this circuit becomes this, because now this 800 ohm will not come into play, because if you have sorted it across this path is basically disconnected, right? So this is your inductor here which is sorted, right? So what's the current flowing in the steady state through this inductor? Depends on this resistance, 800, 1333, 100 ohm, right? And then here is a 12 volt source. So this is the equivalent circuit, right? Before time t is equal to 0. Okay. So the current here would be total voltage. So what's the current here first? Let's find out that. So total voltage is this 12 volt, and what is the equivalent resistance? The equivalent resistance is 100 in series with 800 parallel 1333. Right? So you can solve this, right, to get this. Now, what's the current through the inductor? The current going through the inductor will be a fraction of this current, right? What fraction will be passing through here? It will be this resistance, because more current will be passing from this, right, versus this, because it has less resistance. So it will be the more resistance divided by the sum of the resistance, right? Okay. So this is the, yeah, so we need to solve this, right? Now this requires some calculation. Yeah, so if you solve this, okay, using calculator, then you'll find it will be around 12.5 milliampere. Okay. Now we know what's the current initially flowing just before this was disconnected. Now let's disconnect this, right? So if you disconnect this, then the effective circuit would be this. Okay. Now they're asking what's the current here at t is equal to 10 microsecond. Okay. Now this is a RL circuit, right? This has stored some energy, right, which it will dissipate now across this resistance. So obviously 12, it will, whatever the current would be, right, at 10 is equal to 10 microsecond, it will be lesser than this. Now if in exam the options are such that there is only one option which is less than this, right, then you can immediately mark that answer without solving it. But let's say there are confusing options, then you need to solve this. So what's the current across the inductor in an RL circuit? If you already know, then you can just directly apply the formula, right, where I0 is the initial current, potential e to the power minus R by L. But let's say you don't remember the formula, right? Then you need to derive it. Okay, and that can happen, right? You cannot remember all the formulas, so you need to know how to solve the circuit without knowing the formula. Okay, so we know the potential formula for voltage drop across an inductor is how much? It's given by L di dt, right? And what's the potential drop formula across this? This is IR. The sum of this should be 0, right? sum of, because one will be discharging and one will be not charging, because the resistance cannot charge, right? So because of this current flow, there will be a potential across this and there will be potential across this, and this sum should be always be equal to 0. So actually what it means, that if it is in this direction, the other guy will be in opposite direction, right? Yeah. So if how to solve this, just make it vi at time t is equal to 0 till some time t. What was the current at t is equal to 0? I0, which is this, and this we need to find at time t. So this is di by I is log I0 I minus R by L. Now if you solve this, you will get the equation I is equal to I0 to the power minus R by L t, right? Okay, so the derivation is done. So current at time 10 is equal to 10 microsecond will be 12.5 into e to the power, what's the R by L, right? So it's, so this will be 0.4. Okay, we solve this, it will come out to be around 8.38 milliampere. Okay. Oh, sorry, this is negative.